Hello, all. How are you all doing? It's a final episode of this month, API August. It's coming to an end. It's an exciting topic today. API workloads on Kubernetes. So we're gonna show you how you can run Kubernetes Ingress controller at the edge as well as a multi-Ingress controller. I am Rajesh. As you all know, I've been doing for the last 3 weeks. Rajesh Bavanantham from NGINX, working as a solution architect based in Melbourne. In this episode, we're predominantly getting in the detail of how you could efficiently run this Ingress controller. So Kubernetes, as you all know, it is a buzzword. We can't escape from touching that particular topic. So I'm very excited about this topic, to be honest. Google actually defines this. It's a common definition for Kubernetes. It's an orchestration tool where it helps you to run your workloads efficiently, comparing against VMs. It's more efficient to run this and horizontally scale your workloads however you want it to. So, without wasting any time, let's get into the topic. So, before we get into the demo, just a few news I thought of actually sharing. One of the top news from Nginx is Nginx has gone to two different Ingress controller. We will see that in a minute. One of the Ingress controller is actually maintained by the Kubernetes community, which recently released its version, which is 2113, which you can see. I'm going from the bottom up. The other news, which is exciting, happened in Kubernetes world is there is a UI where it helps you to connect to Kubernetes clusters, which I will show you in this demo as well. I quite heavily rely on that. It's called a Lens. That was acquired by a company called Meraki. It was an interesting acquisition. And the third one was the Docker pricing. Something I just wanted to warn you guys that Docker has changed their policy. They are not going to store your Docker images more than 6 months from now on, until unless you pay. Nothing is free, as you know. And also they're going to put some rate limiting on how many pull you can do on the Docker repository. So that changes is coming as well. Recently, Google announced their V2 networking for where you could use a Cilium on the Kubernetes world, where it actually helps you to apply network level policies on the runtime, which is much more efficient than what they used to have. So that's a quite interesting news. The other one is the Ingress controller, which is maintained by Nginx, which is version 1.8. The latest one is 1.8.1. Have a look into it. It has got some exciting feature, which we will see today. The Also, I just wanted to highlight certain tools which I quite love about. Is The first one is, you can see that it's Kubernetes Goat. That's an open source tool which is actually developed by someone called Madhu, I believe. It's actually used for testing, practicing your security hat with the Kubernetes. So he has developed a vulnerable Kubernetes cluster, and it helps you to go and test your a Kubernetes cluster, how you can actually fix that bit. The other one is Lifebelt. Lifebelt is a tool which is getting popular, and it seems it's actually do some kind of analysis on the Kubernetes workloads, how secure it is, kind of thing. So that's something which looks good. The other tool, which from AWS, is called CDK8, which I quite like about. If you are developing services using Node.js or Java, etc., you could actually now, using this particular library, you can emit YAML file for Kubernetes, which means as part of your CI/CD pipeline, you can actually generate your YAML file using this library. This is quite interesting, something you should be looking in. The other one is from Snake. Snake actually has announced a tool. I think it's called IAC, I believe, IAC. It's actually used to interrogate your Terraform or a Kubernetes cluster. How is there any vulnerability on this one? And as you all know, Snake is well known in this industry, so something we need to look into that. It's a quite interesting tool. The other one is K8 Spin. That's relevant to our topic today. So K8 Spin is they have a multiple open source project. One of the project which I quite like about is, which recently they open sourced probably few weeks ago, where they let you to do a chargeback model on namespaces, Kubernetes namespaces, which we are going to look into it, because today a lot of customers actually trying to have a chargeback model on the namespaces as well, where they give namespaces to a specific LOB or a specific team, where they actually manage their whole namespace by themselves. So this particular project help you to set up the namespaces and do the chargeback as well on top of that. So that's a quite interesting project. Before getting into it, I'm not going to go through step by step on this, but I wanted to highlight one thing here. When you talk about Kubernetes Ingress controller, we actually have the Ingress controller like almost three different versions of it. One of them is the one which is developed and maintained by the Kubernetes community. That's the first column which you're seeing. And it has got a different GitHub repository. The other one, the Kubernetes Ingress for NGINX and NGINX Plus, it's maintained by us. That means by NGINX itself. So there's a lot of differences. I won't go to step by step on this one. This particular slide will be sent to you very soon, so I'm sure you'll have time to read through this bit. One thing which I want to highlight is the JOT validation and session persistence is not available in the community editions. It's only available with the Kubernetes Ingress, which we will see today. That's continuing to that one, so let's not waste any time on that. So this is one of the architecture which we are going to see today by realizing this in Kubernetes. So what I have done is I have chosen two different approaches today. One is running Kubernetes at the edge of your Kubernetes environment, and the other one is to run a multiple Ingress controller. One is sorry, let me rephrase that one. One example is to actually deploy the Ingress controller at the edge. The other example is to show how you can run the Ingress controller at a different level. So the first example, what you're seeing here is a GCP's one, but I have done exactly the same for Azure as well. So this particular architecture actually has a VPC, and the VPC has got an external load balancer, and that particular load balancer actually load balance between your Ingress controller. So that Ingress controller is deployed in a separate namespace. It's called the NGINX Ingress namespace, which I have chosen. You can choose to deploy anywhere you want. That's a separate namespace. And I have also deployed a couple of services here for simplicity. I chose weather service and a hello echo service. So those two services within a different namespace. So here, most of the customers run this way as well. So they have an Ingress controller at the edge, and they actually try to load balance between their services, and they try to protect it at the edge of the thing. So this is one of the example. What I have done is I have realized this in GCP. So you can see the link on the top of the slide, which you will get it as part of the description as well. You can definitely run this code on your own environment. It just runs. All you have to do is just configure it to run against GCP. This particular thing I have deployed inside the GCP. The other one, so this is the multi-ingress controller which I was talking about. If you look at it, the difference is there I have deployed the Ingress controller at the edge in the NGINX Ingress namespace. I have also deployed the Ingress controller, one other Ingress controller in the microservice namespace. The reason for that is this is a pattern which I'm quite heavily watching in the space. It's happening as of now. The reason for that is the edge Ingress controller here can actually start to handle enterprise level security, like applying WAF policies and things. And the Ingress controller, which is running inside that microservice namespace, can take care of your business cross-cutting concerns like a JOT authorization and user-based rate limiting or request rate limiting, all anything to do with the business. So if you can take this particular example, you can fit that into a place where there are multiple LOBs or BUs where they want to own their own namespace. Remember, I talked about that starting of the meeting. So you could actually replicate this one. So you don't have to worry about the edge Ingress controller. Edge Ingress controller only takes care of the high-level enterprise level security, like IP level rate limiting, or even applying WAF policies. So so this particular architecture, I have spin that in GCP. Sorry, I think I changed that bit. So this particular one I have run in GCP. The previous Edge Ingress controller I ran it in AKS. I'll show you the code. Let's get into the demo. Let me stop this.
Hey guys, I'm Cheryl. I'm marketing for NGINX and APAC. And while Raj is switching to his demo, and I think it's almost ready, I just want to remind you to please put your questions and comments in the live chat that you have on your screens. And over to you, Raj.
Thank you, Cheryl. Yeah, please feel free to post some questions. I should be able to answer within time. I hope I'll have a bit more time today. The reason for that is I'm not going to deploy the code today because I have already deployed. The reason for that is I have deployed in two different cloud providers. One is in AKS, another one is in GCP. As you can see, maybe I have to maximize this a little. As you can see that I went, this is a project which we have already shared. Maybe we will share as part of the communication, you will get it. So what I have done is, this is for multi-ingress controller. I went with a module approach in the Terraform, which means all what I did was I have disabled the local module and the AKS module. All I did was enabled the GKE module for this one. So all it's going to do is it's going to actually make a call inside, and it's going to create a Prometheus infrastructure. It's going to create an NGINX plus those namespaces and those NGINX plus Ingress controller which I deployed. So that will be deployed as part of this project. This KIC module is used to actually build the Ingress controller locally and push that to the Google's image repository or Azure image repository. And this GK is what it's actually used to create the VPC and the Kubernetes clusters, the primary nodes and the secondary nodes for the Kubernetes cluster. So this is all already done. The code is right in front of you guys. You should be able to take this with a simple change of actually, changing where you really want it to run. Do you want to run it against your local Kubernetes, or you want to run it against your GCP, or you want to run it against AKS? You can do all of this with this single project. I have two projects. This one I did for multi-ingress, and the other one is the single ingress controller, which actually runs in the edge. We will share both of the code. So here, as I mentioned, I have deployed NGINX Plus on both edge proxy and the micro proxy. The other thing which I wanted to highlight here is NGINX supports the two type of ingress. One is the ingress class, which I'm sure all of you guys would have seen that one. That's what it has been. The first it came up with when ingress controller came into picture. Most of the providers tend to give that approach of actually going and giving that ingress class to use it. There is one other what NGINX actually came up with. It's a custom resource definition. Kubernetes helps you to write your own CRDs to go and define your own ingress controllers and ingress paths. So NGINX has taken a different path, which is more elegant path than the ingress what Kubernetes actually dictated, because the previous ingress only supports a plain load balancer. You can't do like a traffic splitting, or you can't actually use the ingress controller as an API gateway. The attempt to what NGINX is trying to do is to convert the ingress controller to run as an API gateway in the edge, or in the micro gateway in the namespace as well. So that's the path we are going forward. An example of that is this one. So the virtual server and the virtual server route. This is a custom resource definition which NGINX actually supports it as part of the deployment. So here what I have done is I'm deploying this particular virtual server, which is an Ingress, another name for the Ingress, in this particular namespace. So you can see that if you would have used any other Ingress controller, or even in the open source NGINX Ingress controller, you'll see a lot of annotations, which is very, very hard to read. So this particular approach is to actually help you to abstract those things away from you guys, so you don't have to worry about all those annotations. Instead, you actually go and understand the structure, how this virtual route or virtual server defines you the ingress for your APIs. So here, what I have done is I have defined this namespace, and I have started to apply the policies. So this is how we are going to actually define the policies for that particular ingress. So here I have given a simple policy where I say that allow any host, and the namespace should be in this particular bit. So what is this allow any host? So here again, you don't have to go with the annotations. You can define this in a YAML level. It's much more readable. Here the policy defines that, okay, the metadata is this is the name of it, and which namespace I'm going to define this policy, and I can start to write my policy. So one of the policy which we support now is access control. So you can start to define, okay, I only will take access from this particular IP range or something like that. So here, since I wanted to test this from the internet, I just opened it to everyone, but you can restrict it to however you wanted to. And other bit for the multiple ingress controller, which I've been talking about, you have to define your ingress class name. So here I have defined it as an edge proxy. That means as per the architecture, it always runs at the edge. So here I have not applied much of the policy. What I did was I actually say that, so whenever the request comes for the weather service or for the hello world service, go to the upstream. The upstream for the service is always NGINX plus microservice proxy. So the edge proxy routes all the requests to the another ingress controller, which is running inside the microservice namespace. So this particular ingress controller, I kept it simple. The reason for that is to make sure you can apply WAF policies. So as you all know that NGINX actually supports another WAF called NGINX App Protect. So it's very, very easy for you to apply WAF policies here in the edge one. I have not done that because I don't want to overcook today. So, but I can give you a bit of a sneak peek of how that would look like. So this is an App Protect policies, one of the policy which I have defined here. So it's the same way how I defined the other policy, that allow list. So where you can actually say that what type of violations you want to do that. You want to guard against. So one is the data guard, the other one is HTTP protocol guard, and the other one is the threat campaign. So these are all the NGINX App Protect. You can apply the WAF policies to the edge proxy, and your edge will take care of all of this enterprise level cross-cutting concerns that you don't have to worry in your service level or in your LOB or BU level. Going back to this one, and the next ingress controller which I have deployed is this. If you can see, the difference here is I have defined the ingress class name as a micro proxy. So you have to, as part of the ingress controller, multiple ingress controller, you have to define what a unique name for each ingress controller. Otherwise, the Kubernetes, the ingress controller will not run. So here, what I have done is I have actually defined a certain snippets. The other powerful thing about this virtual route, virtual server and virtual server route, is you can go and define your NGINX directives directly inside HTTP snippets. All you have to do is inside HTTP snippets, you can just start to put your NGINX directive. It will work. The other bit which I wanted to highlight here is I talked about splitting the traffic, or doing A/B testing, doing some kind of a canary testing. That is not possible with a normal Ingress class. So you have to use virtual route or virtual server route. So an example what I have given is for the hello world example. If the hello world is this, and I have defined a match condition here. So the condition is I'm checking the request method. If the request method is get, then forward this to the upstream. If not, then forward 405. That means, hey, your method request is not allowed. So this is a simple one which I have defined here. You can actually extend, you can actually apply multiple conditions here. I have only given one condition here. You can apply multiple condition, or even what you could do is at the part of condition, you can check whose cookie is this. if the user belongs to this particular one, I can actually send to a different upstream, which means 90% of the request can go to this particular bit and 10% can go to this particular upstream. So you can actually run two different versions of your microservice, and you can do a conditional routing using this particular virtual route and virtual server route. This is quite an interesting block. I will strongly recommend you guys to pay more attention to this one. This is where we are investing quite a lot. We are actually simplifying the whole Ingress controller concept for the users. So something which is definitely worth looking into it. So now what I'll do is explain to this, as I was saying. Let's get into the actual So this, what I'm running against is, as I said, I already ran this. The infrastructure is ready. I'm running against this AKS, which means I'm trying to create, get the endpoints where I have to hit against to test this bit, test the Ingress controller. The first Ingress controller setup, what we are going to test is the edge one. So this is not a multi-Ingress controller. There's only single Ingress controller runs. And I have applied rate limiting. I have applied, as I showed you in the HTTP snippets, I have applied JOT authorization, which means if I actually try to hit this, so I won't take the authorization. Let's go and test this off. It says, nah, you are not authorized to do this one. So this particular check happens in the edge itself. The Ingress controller verifies and says that no, you're not good enough to move forward. So now what I'll do is actually I'll try to pass the I have secured this API against auth0. That means I need the token. I need to mint the token first. So let me get the So I'll go and issue a request, and I'll get a token here without a valid token and without a valid scope. That will not run. Sorry, wrong tab. That works. So we don't have any problem. As I was saying that I have applied IP-based rate limiting as well. It says that now you can't do it. The rate limiting, what I have actually put that there is like a 3 requests per minute, which means it only takes 3 requests. So that means it has divided the 3 requests, how often you can play that many requests. So if I immediately trying to play, it will throw error. So let's actually try sending post. There you go. So it clearly shows that hey, you can't actually use this one. This method is not accepted. So as part of the condition block which I showed you, it clearly spits out and saying that get out. You are not allowed to use this request. So now moving into the multi-Ingress controller. This is deployed in GCP. So here I have one Ingress controller running at the edge, and the other Ingress controller runs in the microservice namespace where microservice is running. So I have applied all the service-related policies within the second Ingress controller. The edge Ingress controller will have only the IP rate limiting and the WAF policies applied to it. So as you can see, it's a different IP address. It's pretty much it will do the same thing. I'll get the parent token. So here what happens is it actually sends the request. This particular rate limiting exceeded actually happens in the edge of the Ingress controller. So that's where I have applied the rate limiting. I can actually show you that without just explaining it. So let's go to the NGINX Ingress controller, and I can actually show you that. There you go. So here, all I have done is there's only one policy I have done, the limit request zone, and I have applied 3 requests per minute for the IP address. For that's the thing which I have done, and from here onwards, it won't let you to actually go and apply, overuse this particular request. But at the same time, if you go inside the micro gateway, you can see that it actually I have applied much more than that. I have applied HTTP snippets where I can actually go and do the IDP verification. It actually caches those public key and make sure that it actually verifies it against the audience and the issuer to make sure that it is actually have a valid token of it. So that is the difference of running the Ingress controller at the edge. Also, when you're actually trying to run the Ingress controller on multiple places, so it actually gives you an ability to run different level of policy for enterprise and different level of policy for your service specific policies. So that will help you to quickly onboard your APIs without touching your edge proxy. I think how long do we have? Oh, 5 minutes earlier, I have finished this bit. I'll see if there are any question there, if I could ask. One thing I actually forgot to mention is this, the product, the Lens. So that's the one which I quite heavily use. So I could actually connect to, remember I was talking about, this is for my GKE and this is my AKS. So let's say connect to the GK. GK will have a 2 Ingress controller deployed to this one. So this is very, very useful in my opinion. You can see all the events, all the apps. Hold on. It shows all the pods and stuff. So there you go. So I have how many micro proxies. Okay, here I'm running 3 micro proxies and 3 edge Ingress controller. So as you can see, it is actually the pod name is this. Yeah, this is the micro proxy one, and this is the edge Ingress controller. So 2 different Ingress controller, and most importantly, I want to highlight here is it runs in a different namespace, this edge, and if you come to the micro proxy, it actually runs in a different namespace. So to do that one, that's the Ingress class name which I highlighted should be done. Okay, look like you can't see this really, then I can show you that better. So I have deployed this NGINX Ingress controller as a daemon set. You can actually deploy this as a daemon set or as a deployment, which means here if you deploy that as a daemon set, then it will be managed by the daemon set controller, which means there will be only one instance of Ingress controller running for each node. If your Kubernetes has got 3 nodes, that means you will be running 3 Ingress controller. Each node will have its own Ingress controller. If you do a deployment model, deployment is a Kubernetes deployment, that means you can choose how many instances of Ingress controller you want to run, and it will also help you to do a horizontal pod scaling. So both of them have a 2 different use case. If you have a smaller cluster, you can go for a daemon set. That means when I say smaller cluster, that means 3 nodes. If you have 3 nodes, then 3 Ingress controller is good enough to start with. If you have much more, many more nodes, if you want to keep adding to your Kubernetes cluster, then I would strongly recommend you to look into the deployment, Kubernetes deployment, where you can actually configure to do horizontal pod scaling based on the number of requests, or maybe based on the CPU, based on RAM usage. That's the difference between using against daemon set versus deployment. But here, just for simplicity, I used a daemon set. Both ways, NGINX is very, very lightweight, so that's you can run both ways. You don't see any huge difference until unless you get more requests, like a throughput to your Kubernetes. Okay, so is there any questions? To look like I mean, most of us are probably well versed with Kubernetes, but I'm sure running Kubernetes Ingress controller in a different namespaces is something which is blooming A lot of customers are trying that model purely for a chargeback and purely for segregating the policies away from from the edge and to the teams. So that's end of it. I hope that's it. That's not many questions I have seen. So actually, there's no questions. So thank you very much. Thank you very much for attending today. Feel free to reach us. Feel free to email us if you need any help. Of the GitHub projects are already there. Feel free to contribute, or even if you want to see some other feature that needs to be added, I will keep adding more and more feature. If you want something specifically you want to see, please ping me on GitHub, or maybe contact us on our email ID. Happy to help you out. Thank you. That's end of this API August month. See you all soon.